Okay, so let's try this again. So what we got here is a small project that is part of a larger project that I've been working on. So we have a 9-volt battery going into Arduino Mega. If you buy the Arduino Mega bundle pack, there's an adapter that actually goes with a 9-volt battery that you'll put in here. If you use 9 volts into the pin input, it will fry the board. So you don't want to do that. You'll just have to buy another board, and that's no fun. So let's see here. So we got the yellow wire and the black wire. We got yellow positive coming into the VN, the voltage input, and the black ground wire coming into the ground wire of the board. And then we're going to take that voltage from the board, and we're going to go have a 5-volt output and a ground. So we'll zoom back in on that for a second. So you got 5 volts red, ground black. Zoom out, go back over here. So you got your red wire coming into the board where it's closest to the red line. Then you got your black wire coming into the board where it's closest to the blue line. Then you have these two wires here, no particular color. They're blue because, well, they were probably blue when I put them on there in the printing. But, so you got a, this is going to be your voltage in. So, closer to the red, then we're going to put that closer to the red, right? From there to there, closer to the red. And we're going to do the opposite with this wire here. It's going to be closest to the blue. So you got your ground, black ground goes up this rail to this pin here, crosses over to your ground. Then we're going to look at our LED. So we have a ground wire coming over, crossing input here into the LED, out of the LED, into the resistor, out of the resistor, into the white wire, and this is the same for all three of these LEDs. Let's zoom out, zoom in. So we got a blue wire, a green wire, and a white wire. And I have these three wires in accordance with the code that is going to be input into the board. And so we got our blue LED connected to 22, pin 22. Then we got green connected to 24, white connected to 26. And that's our LEDs. So then we're going to go look at our ultrasonic sensor a little. Let's not zoom in too much because you can see it from there. So we got a VCC, so our voltage current. Then we have, and that's red wire connected to our red line, closest to the red line in the red rail. Then we have a ground, that's a black wire. Let's clear that off of there. And that is connected to closest to the blue line, which is our ground line. Then you have these two wires in the center here. So you got a trigger wire, which is the blue. Then you have an echo wire, which is the brown. And that's connected onto our Arduino board here. So brown to 42, echo to 42, blue to 44, trigger to 44. Okay? And then we're going to look at, zoom out. Oh, we zoomed out a lot. We're going to look at our servo motor for a moment. So our servo motor has three wires. It has a brown wire, a red wire, and an orange wire. And you want your brown wire to be connected to your ground, or the rail closest to the blue line. And your red wire, you want input closest to your red line. And then your orange, you want connected to 8. And what this is going to do is, when an object gets within a certain distance of your ultrasonic sensor, it's going to change the degree of your servo motor. And whenever we get to the code portion, we're going to go into a little bit more detail of that. But just to understand the context of what we're doing here. And then we're going to, at a later date, we're going to add another ultrasonic sensor or multiple ultrasonic sensors to triangulate the position of an object. Whenever an object comes within a certain distance of the ultrasonic sensors, multiple, at least 2, can be more. You can make what's called an array of ultrasonic sensors to triangulate the position of an object. You can also do that with microphones to triangulate sound and all those kind of fun things. But for this is what we're going to do. And then you're going to have something, let's whatever, attached to the top of your servo motor. Let's say a squirt gun. And whenever people came within the certain area of the squirt gun, it would point at them and squirt them. Someone's going to get in trouble, but that's okay. So let's look at the code. So here's our code, our Arduino code. Let's scroll to the top. So this, if you've never seen code before, this is C++ code, which is what Arduino works on. Maybe these other languages, I don't know. So we have this library. So we know it's a library because it's hashtag include and then less than servomotor.h greater than. Okay? And that's going to import this library for you to use. So then we're going to go down to these other defined pins, and let's start with our ultrasonic sensor first. I should probably code that in there. Let's drop that down. So we're going to do backslash ultra sensor. Okay, and that's how you write a comment. You can see as I commented here too. One way or another. And then we're going to go down here. We're going to do these. These are our LEDs. And then we got those LEDs. Let's go here. Let's drop that down. Comment. Servo. Which, you know, it's a servo because it says servo. In orange text. Which means it coincides with a library. But let's look at this first. So we got our ultrasonic sensor, and we have it a constant initialization and trigger pin. This is case sensitive, so lowercase trig, capital P in pin, and that's equal to 44. And then you want to put a semicolon. As you get more used to coding in C++, you know you put a semicolon everywhere. It's going to save you a lot of headache. Then we got we're going to initialize it the same way. Then we're going to label it as echo pin equal to 42 semicolon. And that's how we're going to have this set up. Now, if you remember from our fritzing sketch, let's go back to it, and we're looking at our ultrasonic sensor here, and it is connected, follow the wires over, it is connected here, 42 and 44. So that is wired correctly. And then we're going to look at our LEDs here. So we get our, there again, this portion here is initialized the same way. We got a blue pin, our blue LED is connected at pin input 22. Then we got green connected to 24, white connected to 26. Let's go look at our sketch here. So let's back out. We've got our LEDs here. We got our white, green, and blue, and they are connected. Blue is 22, green is 24, white is 26. Okay, then we're going to go back here. And let's take a look at the servo. So if you notice, our servo is a little bit different. It is not defined there on what pin it's connected to. And that's okay. We got this library and we know that this is how we have it defined. So whenever we're calling it later, it knows that's what it's looking for. Let's go ahead and scroll down a little bit, because the next section actually talks about this. So here, so in our void setup, we got our trigger pin is an output, our echo pin is an input, and then these LED pins are also output as defined here. Now, if you see this line here, it has our test servo pin dot attach. Now we have it defined test servo pin. There again, this is case sensitive. You have to write it exactly like you have it defined at the top. And then we have it at pin 8. So let's look at pin 8 again. Pin 8 here is an orange wire. That orange wire connects to our servo motor. So that's correct. Okay, and let's scroll down a little. Then this is our void loop for the ultrasonic sensor. So let's take a look at this. We got void loop, long duration, comma, distance. Okay, mouse is caught up. Alright, so let's look at this first little bit here. So we got digital write. So we're going to be writing something to the trigger pin and turning it low. And then we're going to have a delay of 2 microseconds. Then we're going to go back in here. We're going to digital write trigger pin high. And then we're going to go here. We're going to have a delay microseconds of 10. Digital write trig pin low. And let's scroll down a bit. Look at this section here. Our duration is equal to pulse in of the echo pin high. Distance is equal to the duration divided by 2 divided by 29.1. So in simplest terms, that's just increasing your accuracy. Let's just leave it there at this point. You can put it in, you don't have to put it in. So then we're going to get into our if statement, which is all kind of fun. So this first section, if you notice, these are our a little different. Well, they're all different, but with each if statement, the slightest variation makes it unique. So what we're going to look at is if the distance is less than 30.48 meters, they're not freedom units. We have digital right. Our white pin is going to go high. So if there's an object less than 30.48, it's going to automatically turn our white pin on, and it's going to have our green pin and our blue pin LEDs are going to be set to low, and they're going to be turned off. Then our test servo pin is going to write to 45 degrees. So it's going to, where's the camera? Okay, here, and it's going to turn to 45 degrees. Okay, and then it's going to pretty much be the same thing for our else if statement. So if the distance is less than 60.96, it's going to turn our white LED low, which turns it off. Our green LED is going to go high, turning it on. Our blue LED is going to go low, turning it off. And then our servo motor is going to change to 90 degrees. Right, okay. And then we have another else if statement here. And it's going to change it to else if the distance is less than 91.44 degrees. I mean, not degrees, meters. I may have made a mistake earlier too. That's okay. It's part of this. Get comfortable making mistakes. You're going to make a lot if you code anything. Get comfortable with failure, because that's 90% of it. Anyway. And then eventually you learn, and hopefully it's 80%, hopefully it's 50%, and then as you get more years of experience, you get down to about 10. But I doubt you're ever going to get below 10. Maybe John Carmack, but that's about it. So then you got your next else if statement. And if that distance is less than 91.44 meters, it's going to turn your white LED low, turning it off. It's going to turn your green LED low, turning it off. And it's going to turn your blue LED high, turning it on. And it's going to set the servo motor to 135 degrees. There again, these are meters, not freedom units. So then we're going to get to our last little bit. So if there's anything outside of that criteria, we want it to default to off. We want our LEDs to be turned low, turning them off, and we're going to turn our servo motor to 0 degrees, putting it at reset. And then we're going to end our process. So I'm still trying to figure out how I'm going to show you this in real life, or on camera in real life, not on an Arduino. Like, I'm not going to show the sketch on the fritzing software or the Arduino software. I want to show it in real time how it works, but I don't have a setup for that yet. So this is probably where we're going to stop for now, and whenever I figure that out, I'll put a part 2 up, and you can wire it up. Or if you just want to wire it up on your own, have at it, because that's the information. And of course, you can change these numbers to whatever your heart desires. You can also change these pins to whatever you want as well. Let's look at that real fast. So we're going to go here. So some of these are pulse width modulation, and let's not get into that yet. one way or another. Enjoy.